Wonderful. So what we have so far is a really simple model of human development, right? We've essentially laid down a framework to think about how a child's skills as an adult are going to depend on the investments made in that child over the course of their life. What we want to do with this now is to use this as an input into an economic model that can allow us to ask questions like, how does access to higher quality education later in a child's life, or expectations about that access, influence a parent's decision about how much to invest in the child when they're young? Or how do credit constraints early in life that might reduce the level invested in a child when they're young influence parents' optimal investment in children when they're older? So let's start out with the technology of skill formation that we laid out before, right? Where we said h prime is going to equal h times sigma times I1 to the 1/4. Oh, what am I doing? The 1/4 times I2 to the 1/4. Right? So this is our technology of skill formation. And use it to think through a problem facing a family, a parent of an adolescent. So let's imagine you've got a parent of an adolescent whose value of I1, right, the investments made in them when they were a child, are a fait accompli, right? The parent can't do anything about it anymore. The child's investment when they're young depended on things like access to high quality preschool and parents' credit constraints, right? Their ability to marshal the resources necessary to invest in their children. So we've got I1, H, and theta are all fixed. Right? And let's say that this parent has preferences where they care about two things, right? So their preferences are going to be utility. The two things that they're going to care about are the family's consumption now, right? So the parent and child's well-being in the current period, and the child's eventual level of human capital. They're going to care about C, they're going to care about H prime. And just for mathematical convenience, I'm going to say that the shape of these preferences are going to be C to the 1/4 plus H prime. Might not look mathematically convenient now, but it'll end up being reasonably mathematically convenient. So this is their preferences. Their constraint is going to be that they have a certain amount of wealth available to them right now, which I'll call W, which they can spend on consumption now or investment I2, right? Yes. Wonderful. And of course, they're constrained by the human development function here. So our goal is to figure out what's the optimal level of investment I2, right, given H, theta, and I1. And as a result of that, we're going to be able to ask, how is the optimal level of investment in the child's eventual human capital, going to depend on those things. So to do this, we're going to do basically the same trick that we did when we thought through the Becker model, which is that we're going to take this budget constraint, right, which is in terms of consumption and investment in period 2, and this utility function in terms of consumption and human development, and we're going to try to modify them so that they're in terms of the same variable, right? So we're going to basically have either both H primes or both I2s. Now what we did with the Becker model is that we modified our budget constraint, right? So if we were to do the same thing, we would basically want to find I2 in terms of H prime, so that we know essentially our budget between the two things we care about, consumption and H prime, right, human development. But in this case, that's going to be a little bit ugly to do mathematically, because if we solve for I2 here, we're going to get some non-linear function, right, of H prime, which is going to mean that our budget constraint isn't going to be a straight line. We don't really have the tools to deal with non-linear budget constraints. So what I'm going to do instead, I'm going to rewrite my preferences in terms of I2. Right? So what I'm going to do is I'm going to say U of C and I2 is going to equal C to the 1/4 plus this, right? H sigma I1 to the 1/4 times I2 to the 1/4. This whole thing here is just some number, right? Some fixed number. So this is just C to the 1/4 plus some number times I2 to the 1/4. Make sense? So I don't like doing it this way as much because we don't really believe that the parent cares about their level of investment, they care about their human development, but it's going to work out mathematically. So from here, how are we going to solve this problem? We've got a simple budget constraint, right? We've got preferences. All we have to do is figure out how to optimize our utility, right? We have a budget constraint like this, where we've got C and I2, right? Our maximum C, our maximum I2 are both W. We've got a slope of 1. So we're going to try to find our optimal choice by finding our MRS, saying it equal to the slope of the budget constraint, and then plugging the result into our budget constraint, right? So we can say our MRS in terms of C and I2, du dC over du di2. Good? So what's du dC? Well, the derivative of c to the 1/4 with respect to c is just 1/4 times c to the negative 3/4. And the derivative of some number times I2 to the 1/4 with respect to c is 0. Right? What's du di2? Derivative of c to the 1/4 with respect to I2 is 0. Derivative of some number times I2 to the 1/4 is just 1/4 times that number, right? Times I2 to the negative 3/4. So this whole thing right, is just going to be 1/4 c to the negative 3/4 over 1/4 times all this. The 1/4 are going to cancel out, right? I'm going to bring the negative exponents up, so I can say the MRS is going to be I2 over c to the 3/4 divided by h sigma I to the 1/4. Right? So what are we saying? We're saying that the amount of investment in our child I'm willing to give up for more consumption today, higher the more I've invested in my child, and lower the more consumption I have today, right? Also going to be lower the higher the return on investment my child is. So in order to find where MRS equals price ratio, I just set this whole thing equal to 1. So that's going to tell me that I2 is going to equal h sigma I1 to the 1/4 all to the 4/3 times c. Lovely. And sorry, I actually want to solve for c in terms of I2 since I want to eventually find I2. So I'm going to turn this into c equals I2 divided by this number, right? H sigma I1 to the 1/4 all to the 4/3. Wonderful. So where do we go from here? Well, from here I know c in terms of I2, so I can plug this into my budget constraint, and I can say that my total family wealth is going to equal I2 over this number, right? The 4/3 plus I2, which is going to mean W is going to equal 1 over this number plus this number over this number right, times I2. So I2 is going to equal this number times wealth over 1 plus this number. Right? Okay. Great. So what this is telling us is, essentially, we're going to end up spending a share of our income, right, a share of our wealth, right, a share of our total family resources on our child's education when they're in high school that depends on three things. It's going to depend on our ability to educate our child, right, the productivity of our investments, our child's academic ability, and the investment that our child got in their abilities in early childhood. So what this means is the higher I1 is, right, so the higher this number is, the larger a share of our income, of our wealth in adolescence, we're going to spend on our child's education when they're an adolescent. In other words, the more we invested in our child's early education when they were young, the more we're going to end up investing in our child's adolescent education when they're older. If our goal, right, if we're trying to increase our child's human development. So this is in pretty strong contrast to the predictions of the Becker model, right, which assumes that if a parent knows that their child's going to do better later, right, or if you give resources to a parent's child, the parent's going to take some of the resources they were going to invest in the child and bring them back to current consumption, right, so that anything you do for a child is muted by family dynamics. In this case, increasing a child's early education is going to actually have enhanced benefit through family dynamics because it's going to increase the benefits of investing in the child later. Now, that particular conclusion rests on some of the particular assumptions we've made, right? The functional form we've made here, the preferences we made here. But this possibility is really what Heckman's interested in exploring. Now, looking just at this tells us a couple of important things. One thing is that whereas Becker says that we should care about credit constraints, right? We should expect that low-income children will be less educated if their parents aren't able to borrow against their future incomes when they're deciding how much to invest, right? In other words, we can't have negative values of YT. Heckman's going to say we should care a lot about when in a family's life credit constraints occur. So if it's the case, as it is in real life, right, that parents of very young children often have very low incomes, right, because they're younger, they're newer to parenthood, etc. That might concern us, even if credit constraints don't play a big role in children's decision about whether or not to go to college, which he claims some of the empirical evidence suggests doesn't play a massive role in children's decisions to go to college. It's also going to suggest that once we have kids who are disadvantaged in high school, right, once these early child investments haven't been made, if our goal is simply to increase the total skills of the workforce as much as possible, right, to increase GDP as much as possible, then we're not necessarily going to want to direct investments towards disadvantaged kids, right? If our goal is to just invest in the most productive kids, right, the kids where there's the highest return on investment, these dynamic complementarities, the relationship between early and later investment is going to lead us to want to invest more in the adolescents who got the most investments when they were kids. But that's not necessarily true in early childhood as long as we follow up those early child investments with later investments. In other words, if we're thinking about who, we want to increase the number of doctors in the country, if we're thinking about who to send to med school, out of all the people who have finished college, we're going to want to send the people who got really, really good grades in college in biology and chemistry and stuff like this, who are not going to be disproportionately disadvantaged, right? They're going to be people who went to excellent schools, got excellent grades, had excellent help. If we're thinking about who we should, provide educational resources to increase the number of doctors among people who are 3 or 4 years old right now, then we might say there's lots of high ability, low income children who are going to miss out on some very, very, very productive early childhood investments if we don't help. So even if our goal is just to increase the total number of doctors, increasing early childhood investments for disadvantaged children can have these snowball knock-on effects as long as they're followed up by later childhood investments. Okay, great. So this is all I'm going to do in our lecture videos today because I don't want to make you watch ultra long lectures twice in a row. But when we're exploring these models together in class and when we're exploring them in the problem set, we're also going to look at the flip side of this exact problem. In other words, we're going to think, in this problem we thought about how do decisions made when a child was young affect decisions made when the child is older. We'll also be able to use this exact same framework to think about how do expectations about the quality of a child's high school, right, I2, when a child is older, affect parents' optimal decisions about how much to invest in their child when the child is young. Okay, with that, I'm going to leave it there. Thank you so much for bearing with me. I'm looking forward to talking to you about all of this very soon.